Last week we started talking about gravity, and we learned that gravity is a force that pulls matter down towards the center of the Earth, right? It's basically the force that causes things to fall down. Now, that could be a problem if you fall off your bike or out of your seat, obviously, but over the years, people from all over the world have found have figured out amazing ways to use gravity to their advantage, right? How can I work less and make gravity work more? That's what people have figured out. So, today we're going to be talking about how gravity can be put to work. So, I'm going to read this page from You Wouldn't Want to Live Without Gravity. And then in this video, you're actually going to be asked to draw a picture in your notes and describe how gravity is causing an hourglass to work, which is right up here. So, pay special attention. Putting gravity to work. Gravity is always there. It is never turned off. It needs no power source, and it costs nothing. So it's smart to put it to work. We make gravity work for us in lots of different ways. People were making use of gravity long before anyone understood how it works. They exploited gravity's favorite trick of making things fall down. But they also used it to make sure surfaces were perfectly horizontal or vertical, and to measure time. Nowadays, we even use it to direct spacecraft. So let's look down here. Gravity makes a weighted string hang straight down. So by making a plumb line, which is a cord attached to a weight, we can check to make sure verticals are straight. So here you see he's checking to see if the side of this block is straight, and he's got this plumb line right here, right? A weight on a string, and it's going to hang perfectly straight down thanks to gravity. So if this line is straight, you know that the side is flat. If it's angled one way or another, you know it's not. How about this one? Have you ever seen bumpy or slanting water? No. Water will always form a smooth horizontal surface, right? A smooth flat surface. This means it can be used to show whether or not a surface is flat. Simply place a bowl of water on the surface and see if the water is at the same level all around the sides. If not, the surface isn't flat. Easy. So you can see here in this picture, it looks like this surface is not flat, right? Because this water is all sloshed over to one side. So obviously the surface isn't flat. All right, oops. Before clocks were invented, hourglasses were used as a way to measure time. An hourglass depends on gravity because it works by sand falling steadily through a small hole as it flows from the top of the glass to the bottom. It takes exactly the same amount of time for the sand to fall every time the hourglass is turned over, which means it's a reliable way to measure time. Okay, so I guess gravity is pulling these sand particles down through the hole. How about this? A watermill, that's this over here. A watermill harnesses the force of falling water using it to turn a wheel. So you see the water's falling and it's turning this wheel. The wheel turns an axle which drives machinery. The mechanical power can be used to grind corn, right? So this turns, it's turning something inside the building, which is grinding corn. Why grind it yourself when gravity can do it for you, right? A hydroelectric dam also uses the power of falling water, but it's much bigger than a watermill. A huge cascade of water drives machinery that generates electricity from the waterfall's power. Electricity from gravity. Okay, and finally, Earth's gravity isn't the only gravity we can use. Spacecraft boost their speed with a gravity assist maneuver using the gravity of another planet as a slingshot. Gravity pulls the spacecraft in, making it go faster and faster, and then it speeds by the planet, changing direction slightly, but keeping its speed. So if this spacecraft wants to gain speed, it just kind of gets close to the planet. The planet's gravity is going to pull it in, it's going to speed up, speed up, speed up, and then shoot off into space. You can do this if you want. Make your own plumb line by tying something fairly heavy to a piece of thread or thin string. Use it to check how straight and vertical some of the things are around your house. How straight is your door? How straight is that jungle gym? Okay, so now that we have some ideas of how we can use gravity to do work, let's draw our first picture on our page 17 notes. This is the hourglass box. So what I've done, and you can draw yours differently, but what I've done is I've drawn an hourglass. We've got sand particles here and at the bottom. I've drawn arrows to show that gravity is pushing everything down. So the gravity force is going down. And then I wrote a really quick sentence. Gravity causes the sand to fall to the bottom. That's what I'm looking for in all of your boxes. A drawing, arrows showing what gravity's doing, and then a quick sentence explaining what's going on. Okay, go ahead and follow the rest of the directions in your Google Class.